Welcome, architects and developers. Today, we are diving deep into the Claude Agent SDK and tool integration. Let's get started on transforming Claude from a conversationalist into an action-taking agent. Welcome to the core of agentic architecture, the Claude Agent SDK and tool integration. Out of the box, Claude is brilliant but isolated. It doesn't know today's weather, and it cannot update your company's database. Tool integration changes everything. By providing Claude with specific tools, you bridge the gap between its static training data and the real-time, dynamic outside world. We define what tools are available, and Claude intelligently decides when it needs to use them to fulfill a user's request. This is the difference between a simple chatbot and an autonomous enterprise agent. Let's dive into how this powerful system works. Looking at this flowchart, you can see the transformation from a basic query to an agentic workflow. The user makes a request. Claude analyzes it, realizes it lacks the necessary context to answer accurately, and requests a tool execution. Your local system fetches the fresh data, feeds it back to the model, and Claude then generates a fully informed, highly accurate final response. Now, how does this actually run in code? It's all about the agentic loop. This is a critical concept for the certification exam and for production environments. When Claude processes a request, it returns a metadata field called stop reason. If that reason is tool use, Claude is explicitly telling you it needs to execute a function to proceed. Your code runs the tool, appends the result, and loops back. If the reason is end turn, Claude has finished its task. A massive anti-pattern to avoid is trying to parse Claude's text to see if it says, "I am done" or "task complete." Always rely programmatically on the stop reason to control your loop deterministically. This state diagram maps the exact heartbeat of your agentic system. The request enters the evaluation node. If the stop reason flags tool use, we transition into the execution state, run our backend tool, append the result, and immediately cycle back to the API. This cycle repeats dynamically until we receive the explicit end turn signal, safely terminating the loop. Let's look at implementation. A tool consists of two distinct parts, the actual Python function that does the heavy lifting and a JSON schema that describes it. The schema is literally Claude's instruction manual. It contains the name, a detailed description, and the required input parameters. Here is a massive exam tip. Your tool description is the routing mechanism for the LLM. If you write searches data, Claude will guess and it will fail. You must write explicit descriptions like searches customer database by email or phone, returns empty array if none found. Furthermore, practice defensive design. Write Python logic that throws clear errors if Claude passes a bad parameter, so the model can read the error and self-correct its next attempt. In this class diagram, we see the dual nature of an agentic tool. The JSON schema on the left is the interface exposed to Claude, detailing the precise name, a robust description, and the expected payload. This declarative interface maps directly to the actual Python function on the right, which contains your backend validation, business logic, and execution steps. When Claude decides to use a tool, it doesn't just send back a simple string of text. It returns a multi-block message. This payload typically includes a text block where Claude explains its reasoning, followed immediately by a tool use block containing the target function name and its required input parameters. Your code must parse this array, extract the inputs, and execute the function. But here is the most critical architectural requirement. You must append this entire multi-block structure to your conversation history. If you only save the conversational text and strip out the tool blocks, Claude loses its working memory of the tool call, and your agentic loop will completely break down. This diagram deconstructs Claude's multi-block response. The response splits into two concurrent blocks, a conversational text block meant for the end user and a programmatic tool use block meant for your system. Your backend server reads the tool use block, extracts the unique identifier, target name, and parameters, and passes them down to execute the local Python function. What happens when a request is incredibly complex? We enter a multi-turn conversation. Claude might need to query a user's ID first, and then in a completely separate turn, query their recent orders. Your agent must handle this looping sequentially. To scale this, architects implement a tool route array central Python function that takes the tool name from Claude and routes it to the correct backend method via an if/else structure. Crucially, as you pass the execution results back to Claude, you must wrap them in a specific tool result payload that includes the exact tool use ID Claude generated. This strict ID matching is what guarantees Claude connects the incoming result to the correct original request. Watch the sequence here carefully to understand multi-turn logic. Claude initiates the chain by requesting getDate with ID x1. The router executes the backend API and returns the result matching that ID. But Claude isn't done. Realizing it needs more data to complete the calculation, it autonomously initiates a second turn, requesting addDays with a new ID x2. The router handles this follow-up seamlessly. Let's cover a major architectural best practice that is universally tested: tool distribution. You might be tempted to give your main agent access to 20 different backend tools for maximum flexibility. Do not do this. Giving an agent too many tools severely degrades its selection quality because it has to evaluate every single option, leading to decision fatigue and hallucinations. The enterprise standard is 4 to 5 highly relevant tools per agent. If your system requires more, you must distribute them across specialized subagents using a hub-and-spoke model. Furthermore, if your workflow absolutely requires a specific tool to run, don't leave it to chance. Use the tool choice parameter to force the exact tool invocation. This visual proves the hub-and-spoke tool distribution model. Instead of a monolithic agent overwhelmed by a dozen options, the coordinator simply routes the conversational intent to a highly specialized subagent. Notice that the billing subagent, tech subagent, and HR subagent each only possess the 4 tools strictly necessary for their domain. This isolation ensures flawless tool selection. Let's cement this architecture with a real-time use case: the reminder agent. Imagine a user says, "Set a reminder for my doctor's appointment a week from Thursday." This is complex. Claude inherently doesn't know today's date, struggles with future calendar math, and certainly can't set alarms natively. But with our Agent SDK, Claude autonomously orchestrates a multi-turn solution. First, it calls getCurrentDaytime to anchor its timeline. Then, it passes that data into addDuration to Daytime to accurately calculate exactly when next Thursday is. Finally, it triggers setReminder to push the payload to your backend database. It bridged its own limitations flawlessly. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This Gantt chart maps the sequential execution timeline of our reminder agent. First, it anchors reality by getting the current daytime. Immediately following that successful turn, it processes the duration math. Finally, in the third sequential step, it triggers the setReminder tool to finalize the task. It is a perfect, autonomous pipeline demonstrating the power of the SDK.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.